All right, so folks, we need out our pencil, our ruler, our protractor, your calculator. The calculator is to help you do some conversions if you need them, and your Unit 2 packet. Please open up to page 5. While you're getting that out, let me just go over the assignments that are up here on the screen. On Monday, you're going to take a quiz on all of position, distance, and displacement, all of Unit 2A, including the stuff we did over the last couple of days and what we're doing today. The written assignment for Monday to help you get prepared for that quiz is on pages 7, 8, and 9 in your packet. 7, 8, and 9. There's 14 questions total. The first 13 are multiple choice. The last one requires you to draw things out the way I'm teaching you to do it today with your ruler and your protractor. So there will be no calculation. It's all drawing. The entire thing is drawing using the method I'm teaching you today. And before we leave today, I will be handing back your Unit 1 test. I'll talk to you about how test corrections are done. There's a little blurb here about how that's done to remind you, but we'll talk about that at the end, right before I hand back your test. Okay, I'm not handing them back now because I know if I do that, this entire lesson is in one ear, out the other, because you'll be focused on your test. I just know that. So let's go to page 5 and 6 in your packet. And let's start with page 5 right here. And we're doing all of this with rulers and protractors. Again, the only reason we have a calculator out is to help us if we need to do a conversion, okay? Oh, then you're going to just have to follow along. All right, so question number 8 says that we have a child riding their bike from their home and they're going to their friend's house. And it takes them along a route which is 40.0 meters to the east and then 40.0 meters at 45 degrees. First thing I want to know is how much distance the child is traveling to get to the friend's house. This is a review question. This doesn't involve anything new. Remember that distance is a scalar measurement. So what are we going to do to come up with that answer? Should be easy. What do we do? 40.0 meters plus 40.0 meters. And that's going to give us what for the distance traveled? 80.0 meters. That's right. We got to keep the precision because we are adding things together. That's the rule for adding. Okay, part B is the new part. It's asking us for this child's displacement as they go from their home to the friend's house. And we're going to draw it out using the scale that's here. The reason we need a scale is because if I were to draw it actual length to figure this out, 40 meters is like from here to the main entrance. I don't have any paper that's that big to do this. So we shrink it down using a scale so it fits on our paper. And then every centimeter we draw will represent 10 meters of real distance. Now, before we start doing anything, I know none of you have taken the Regents physics course before. So it's really important that you follow along because I'm going to teach you the method the Regents wants you to use to make these drawings. And I'm going to hit all the little picky things that have to be there to get the points. Without these little picky things, you get nothing. Okay? So the first thing we have to kind of do is visualize in our mind what quadrant is this displacement going to be in. If the student went to the east and then turned and rode their bike at a 45-degree angle, where would they end up? In what quadrant on the XY axis? 1, 2, 3, or 4? 1, right? East is to the right. 45 degrees is halfway between 0 and 90. So they end up in the first quadrant. We're going to make a note of that. Quadrant 1. This is a quadrant 1 question. Now, the reason I'm asking you that is because we have to figure out where we're going to put a reference line. This reference line is the x-axis. We need to draw it somewhere in this answer space so that way we don't go off the paper. Quadrant 1 is up and right, the upper right area of our XY axis, which means if I don't want to go off the page, I'm going to have to put my x-axis towards the bottom of this answer space. Does that make sense? Otherwise, if I put my x-axis here and I got to go 40 meters this way and then 40 meters this way, now I'm up on top of this. That's no good. I need to use the blank space. So with your ruler, let's go ahead and draw a nice horizontal line. This is our x-axis. We are going to label this with an arrow to the right. That is the positive x direction. And the positive x, we should recall, is equivalent to 0 degrees and east. Okay. Now, the next thing we're going to do to help us draw this out is we're going to pick where we want our origin to be. Again, thinking about we don't want to go off the paper. So if I have to go east and then at 45 degrees, that's up and right, I'm going to want my origin somewhere over here on the left. Otherwise, if I put my origin here, I'm going to end up off the paper. No good. So let's make a little mark here. That's our starting point, which is the origin of the XY axis. Okay? This is just to get the problem set up so we can draw. The next thing we're going to do is draw a vector that is equivalent to 40.0 meters east. So in this scale, I would figure out how long an arrow I'm going to draw by taking the actual length, 40.0 meters, and dividing by the 10.0 meters. So that's going to give me what? Exactly 4. Now, watch how we do this. We're going to use our ruler, of course, to measure out exactly 4 centimeters, starting from our origin. Now, you got to be careful about this. If you are off by even 1 millimeter, you are one little line right or left to where you should be, your final answer is going to be out of the tolerance range for the final answer, which means it would be marked wrong. All right, so I need you to be very careful about how you draw these. Do not be sloppy. So what I'm going to suggest you do to make sure you are not sloppy and you get every point you possibly can, you see where my 4 centimeter mark is here? I'm going up to that horizontal line and I'm just going to put a little dot right there. That's all you need is a little dot at the 4 centimeter mark. Just a little one. Now take your ruler away. And what we have to do is show that this child rode their bike to the east, which is to the right. So everyone, please put your pencil at that little dot you made on the line. And what we have to do is put an arrow at this point. And the way we do that, if your eyes are on the screen, you'll see, we take this and we pull back from there. I want to make sure the distance between here and here stays 4.0 centimeters. It's not 4.1 or 3.9. So to make sure it's exactly right, we go here and we pull back to add those arrowheads. That way we're not adding any length to it. We now can go ahead and label that. That is 40.0 meters. We don't have to label east because we already did. We said arrows to the right are the east direction. Okay, any questions on that first vector? Okay, the second one is harder. And the reason the second one is harder to draw it out is because it's not east, it's not north, it's at exactly 45 degrees. This is where we're going to learn how to use our protractors that you've had to purchase for this class. And I know you've never used these before, so let me go over some things with you. Everybody's protractor is a little different, and this is why I really need you to use yours to make sure you get comfortable with it. So the first thing we need to do is we need to figure out there is an origin on your protractor. That origin on mine is where this hash mark and this hash mark meet up. It's right here. For some of you, you have a little hole on your protractor at the origin. Okay, you have to kind of figure out where that is. Can everybody kind of point out where yours is? You know where it is? Okay. When we do this next vector, we have to say we're going to go 45 degrees up and right here. So this is going to be the origin for the next vector we draw. Please put your protractor's origin on the dot right there. And I want to come around and make sure we all have it in the right spot. The next thing we're going to do besides it being in the right spot is we are going to line up our x-axis that we drew, line it up with these 2 marks labeled 0 or 180. Can you do that? I want to just check that these are all positioned correctly, because if they're not, the rest of this is a disaster. I just want to make sure we're good. You didn't get the other one, you gotta get the other one first. Get the other one first, and then you can put it in the right spot. Good. And I'm only checking because I know they don't teach you how to use these in geometry, do they? It's like, okay, yours is a little different. Your origin is actually right there. So this part lines up here. See how this line up there? Your extended origin okay, that's your origin. This is what I got to check to make sure we all understand. Yeah, this is this side is off. No, no. Actually, your protractor's upside down. See how the original backwards? And this way. So yep, that looks good. Looks good. Looks good. Okay. All right. So this is where we line things up. Now, the next thing with these protractors is you'll see all of our protractors have two sets of numbers on them, right? This is a 0 or it's 180. And same thing over here. This can be 0 or it can be 180. In our class, we always use this side as 0. To the right is always 0. Always. So we're not really going to look at these numbers on the outside. What makes this tricky is that the numbers on the outside are the ones with the little marks, which tell us how many degrees, individual degrees. So we're going to use this more as just a reference for a size of opening. Okay, so I need to measure 45. Let me show you how I do that here. I'm going to start at 0, and I'm going to count counterclockwise. 0, 10, 20, 30, 40. But I have to get to 45, which means I need to go to 5 little lines over, which would be this one here. So this isn't 40, 41, 2, 3, 4, 5. This little spot. Please put a little dot on yours at your 45. Counterclockwise, starting at our positive x. That's exactly what we did, is we just went 45 counterclockwise. Everybody okay with that? Just a little dot. Now you take your protractor away. That dot is so little. It's okay. We're using it just as a guide to make sure we draw this next arrow in the proper direction. We need it to be 40.0 meters long. In this scale, again, that's going to be 4 centimeters. So with your ruler, here's how we do that. We start at the dot here, and I usually put my pencil there with that to make sure I'm on that point. And then I need to rotate it until I get to the dot that I made for my reference at 45 degrees. And I want to measure out to 4 centimeters. Now, let me give you a hint. Again, we do not want this to be 4.1 centimeters long. It's got to be exactly 4. So I'm going to start my pencil at the 4 centimeter mark and go back towards the original arrowhead that I drew. So that way, that line segment I just drew from here back is exactly 4.0 centimeters. Everybody follow me on that? Just trying to give you some hints to make sure you're not off a little bit. Okay, now we have to add an arrowhead to this end. So put your pencil at the very end and pull back on both sides. So we have an arrowhead on that, showing we now went up and right. We're going to label this 40.0 meters, comma, 45 degrees. Since it is not on the horizontal axis, we label the direction. We are going to erase the little reference dot that we made at 45 degrees, so it's not part of the question anymore. The last thing we're going to draw is the displacement vector in this picture. You're going to do it in pencil. I'm going to do it in red pen so you can see it clearly. We need to connect our original starting point. This is now our end point. We need to connect those with a line segment from here to here, exactly that length. So with your ruler, you're going to connect those 2 points. Okay, now I did it in red so you can see it a little more clearly on the screen, the difference. This is the displacement. We need to put an arrowhead on it to show the direction this way. It's got to be at the very tip again. Add an arrowhead. So it shows that this kid actually ended up there. It's like you're pointing from their home to where they ended up. We're going to label that D with the arrow, and that's what I want to know. What is that displacement? We're not going to use a calculator other than to maybe help us with the conversion. The first thing we're going to do is figure out its magnitude. That means its length, its size. So with your ruler, please measure that. We're going to measure to the 10th of a centimeter. You see it wants us to go to the tenths. So measure to the 10th of a centimeter. I'm getting 7.4 centimeters when I do it. Are you getting about that? Okay. In this scale, 7.4 centimeters would be 74.0 meters. So off to the side, I'm going to indicate that my displacement is 74.0 meters. Now, you do get a tolerance. You get 0.2 of a centimeter. So in this problem, we would allow you to be plus or minus 2 meters. So you would have to be between 72.0 and 76.0 meters to get that part of it correct. The second part, we know we have to give it a direction. Protractor again. You're going to put your protractor's origin back at the original starting point. Line it up. And we're going to measure from our 0 counterclockwise until we hit that line. And when I do that, I'm getting to 22 degrees. Are you getting that? From here to there, that opening to my red displacement arrow is 22 degrees. Are you getting about that? You get 2 degrees of leeway. So the correct answer is 22 degrees. I'm going to give you 2 degrees of leeway. That means I would take anything from 20 to 24 degrees. This is why if you're not measuring very carefully as you draw it, you're not going to be within these tolerances, and then it gets marked wrong. You understand what I'm saying? This cannot be done with Pythagorean theorem or SOHCAHTOA. It cannot, because this is not a right triangle. There is no 90-degree angle in here. So there is no other way for us in this class to solve it other than to draw it out to scale. Now, I know some of you know the laws of sines and cosines, and you can use those, but not when we tell you you have to draw it, which is what this exam is going to ask you to do. If you come back next year for AP, absolutely, you're going to learn how to do it with the laws of sines and cosines, but not this year. All right, let's go to number 9. Similar question where we have a group of friends hiking in the Catskill Mountains. We're going to take a trail which heads 30.0 meters to the west and 50.0 meters at 210 degrees. The first thing I want to know, review question, how much distance did your group travel? So what are we going to do to come up with the answer? Let's show our work. Who could tell me? What are we going to do to get the answer? I heard the answer. Just tell me what you did. Excellent. So that's going to give us 80.0 meters. Next part wants the displacement. Remember in the last question I asked you what quadrant this is going to get drawn in. So look at these two things. West and 210 degrees. What quadrant is that? 1, 2, 3, or 4? Where is 210? 1 is between 0 and 90. 2 is the next area from 90 to 180. This is beyond that. So where is it? Quadrant 3. Okay. So I want you to think about where we should put our reference x-axis in this space. Quadrant 3 means we are below the x-axis. So where do you think I want to put it? Near the top of this answer space so I don't have to draw off the page, because that would not be good. I'd have to erase everything and start all over. Here's my reference line. Positive x to the right. That's our 0 degrees and east. Now we have to think, where should I put the origin? On this line, where should we put it? Think about it. We're going to go west, which is which way? West is left, and then 210 is down and left. So where should I put it? On the right side, yeah. Okay, So the first one we're going to draw is 30.0 meters. In this scale, how many centimeters is that? 30 divided by 10, 3. So exactly 3 centimeters going left. West is left. So we're going to just put a little dot on that line at the 3 centimeter mark. Little dot at the 3 centimeter mark. We can remove the ruler and then pull back to add your arrowhead at exactly that 3 centimeter mark. We label it 30.0 meters. We don't have to put the direction because it's to the left, which is opposite of what we drew as our reference, east, left. Now we have to go 210 degrees. We have a little issue with our protractor. All of our protractors only go from 0 to 180. This is beyond it by how many degrees? 30. Okay, here's what we do. We can turn our protractors upside down. We're going to put our origin at the head of this vector. Line it up. And the reason I'm doing that is because left is exactly 180. So I know from here around was the 180. So I'm just going to keep going another 30 beyond that in the counterclockwise direction. So this is 180, 190, 200, 210. You see how that works? Make a little dot there at the 210 degree spot, which would be 30 beyond the 180. We now pull that out and we're going to try to measure out 50 meters. 50 meters in this scale is 5 centimeters. Okay, so from here to where we start needs to be 5. Add my little arrowhead pointing down and left. I'm going to erase that little reference mark that I made so it doesn't get involved in the question. Okay. We're going to label it. This is 50.0 meters, comma, 210 degrees. We label the angle so that way we know exactly what that's supposed to be. Now we're going to draw in the actual displacement vector, which connects our start and end points. There it is. Arrowhead on it going to the end point right there. That red arrow is the displacement vector, and I want to know its magnitude and its direction. So the first thing I'm going to do is measure its length to determine its magnitude with the scale. Oh, I'm getting 7.9 centimeters. Are you getting that about? Yes. Okay, so 7.9 times 10 would be 79.0 meters. Again, plus or minus 0.2 of a centimeter, so that's plus or minus 2 meters is what I would allow that to be, between 77 and 81.0 meters. Now I got to come up with the direction. When we do the direction, ignore the 2 arrows I drew in pencil. Just look at the one in red. From here to here is 180. We have to go beyond it by that little amount. That's like the reference angle that we were looking at before. That's what you measure with your protractor, is that little amount. So let's do that upside down. From here to the red arrow, I'm getting 19 degrees. You should be getting within 2 of that if you've drawn it correctly. Okay, so if this is 19 and that's 180, what's the actual direction? 199 degrees. You're going to be given 2 degrees of leeway on that, so your final answer should be somewhere between 197 and 201 degrees if you've drawn it within the acceptable range that's allowed. Any questions on number 9? Okay, let's kick it up a notch. We have a grizzly bear that's going to look for food. It's taking a path which goes 15.0 meters to the east, 20.0 meters to the south, and then 25.0 meters at 300 point degrees. How much distance does that grizzly bear travel? To get the distance, what are we going to do? Just add them up. 15.0 meters added to 20.0 meters added to 25.0 meters gives us, what did you say? 60.0. Good. That is correctamundo. All right. Letter B. Now I want the displacement. Okay. First thing, what quadrant does this grizzly bear land in? It goes east and then south and then at 300 degrees. 1, 2, 3, or 4. Yeah, this is 4. Quadrant 4. So where do you think I should put my x-axis? Yeah, top of the space. Label the positive x direction, which is 0 degrees or east. Since we're quadrant 4, that means I want to put the origin towards the left side of the space so I don't run off the page on the right, because I'm going to draw everything going right. So the first one is 15.0 meters east. In this scale, how long are we going to draw that? 3 centimeters is right. 15 divided by 5 is 3. So we're going to measure out that 3 centimeters, make a little mark there, arrowhead at that point. We're going to label that 15.0 meters. Now, south is which way? Down. You can't eyeball it. You have to do it with the protractor, because if you draw it accidentally at 89 or 91 degrees, not perfectly perpendicular to that, you got a problem with your final answer. So what I'm going to do is turn my protractor this way, line it up, and make a mark here at the 90 degrees so that way I go perfectly down in the 270 degree direction. Do you understand what I mean by that? You can't eyeball perpendicular. You have to measure it out. That's why you have a protractor. So now, how long is that one going to be? 20 in the scale is 4 centimeters. So we're going to start here, go in the direction of that dot you just made, and it needs to be 4 centimeters long. Arrowhead pointing down, label it 20.0 meters. We already know it's south because it's exactly perpendicular to that one. Now we have to do 300 degrees. And this one is tricky because we don't have a reference line. But we do. We have this line, which is now the y-axis. So I can use that as a y-axis. And if you think about it, if this is the y-axis, 300 degrees is over here. Let's use this as the downward one, which means how many degrees do I need to measure that way to get to the 300 degree mark? This is from here to here is how many? 90. And how many more here? Right, because that's 360. So this is a 60 degree opening. What's 90 plus 60? 150. So turn your protractor like this. We can line that up with the vertical one we did coming down. And we'll start here at the positive y. We need to go 150 this way. Here's 90, 100, 110, 20, 30, 40. 150 would be right here. Make a little dot there at 150. You understand what I just did? I need something to give me the reference. Okay, and I have a perfectly lined up perpendicular line to this, so that's what I'm going to use. I measured 150 from here around. This was where my origin was at that point. Now, this one needs to be 25.0 meters. 25 divided by 5 is 5. So let's measure from there in the direction of that dot, 5.0 centimeters. Arrowhead on the tip of this, pulling back. And I'm going to erase that little reference dot that I made. Label that 25.0 meters, comma, 300 point degrees. Next step is to draw in the displacement, which gets us from the start to the end point. So you're going to connect those with your ruler. Connect your starting point and your ending point with your ruler. That line segment. The grizzly bear ended up here, so we put an arrowhead at that ending point. This is the displacement that we're looking for. We need its magnitude and its direction. Let's get the magnitude first, measure the length. I'm getting 10.0 centimeters. Are you getting about close to that? So 10 times 5 would be 50. I have to express it with the same precision. So this displacement would be 50.0 meters. Now, 0.2 of a centimeter in this scale is 1 meter. So you get 1 meter of leeway on that. Now we're going to measure the direction. We have to go all the way around like this. Remember, from here to here is 180 degrees. So I'm going to turn my protractor upside down to just measure from the 180. How much is left? So if this is 180, 190, this gets me all the way to 270, 280, 290, 300. I'm getting 302 degrees. You're going to be given 2 degrees on that. Do you understand? The other thing you could do is measure this and then subtract it from 360. I prefer to start here. 180, 190, 200, 210, 20, 30, 40, 50, 60, 270, 280, 290, 300, 301, 302. That is my final answer. I box it in. These are a pain in the rear end to grade for me, because I have to measure every little thing you did. I got to make sure you got every little arrowhead, every little label, and that these are within. So when the Regents exam comes up, I do not it. I'm not grading it. I don't want to grade it. Nope. Somebody else can grade all of these for the entire school, because that's what happens. All right. Your homework are the next 3 pages. 7, 8. Those are all multiple choice. Number 9. Please make a note on this page. Ruler and protractor only. No calculations on this page. This is done with the drawing. This is your drawing question to make sure you understand it. I don't want to see Pythag or SOHCAHTOA on this page. It's a scale diagram, okay? Ready to talk about your tests? Test 1. Okay. First thing I want to do is talk about test corrections. I'm not going to hand it back till I talk about test corrections. On our Google Classroom, it tells you that if you're eligible to do a test correction, you have until next Friday to do it, October 3rd. Okay? You get 1 calendar week to do these. Unless there's a vacation week in there. Then, of course, I'll give you more time. Here's how we do them. If you're eligible, it's because you missed a multiple choice question or 2 or 3 or more. Those are the only ones you can correct for points back. And you don't get full credit. To get full credit, you got to get them right the first time. You get half credit back. So each multiple choice was 5 points. So if you got 2 multiple choice wrong, that cost you 10 points on the test. You correct both and they're right, how many points are you going to get back? 5. And I just wipe out your grade in Aspen and I put the new grade in there. Okay. Here's how you get the points back. If you're eligible because you missed multiple choice, I should have stapled one of these test correction worksheets to your test. If I made a mistake and didn't staple it, come up, I have extras. I will give you one. I'm telling everybody now because this is how every test gets corrected. So pay attention. You may not have them this time, but you might have them next time. This is your extra credit for the class because these are optional, but I strongly encourage you to do them. So notice on this, it says you have 1 week to turn in your test corrections for the multiple choice only on your test, and you earn half the points back. This test correction sheet must be attached, meaning stapled, to your test booklet and your answer sheet when you turn it in. Otherwise, because there's multiple versions of the test, I don't know what question you're correcting number 1. I don't know what version you had. I don't know what question 1 was. I can't possibly give you any more points back. Notice the other thing that's required. You see what it says right here? Without that signature, you get nada. You know what nada means? No. 0. I'm not even looking at it. Okay? I'm not even going to look at it. You need to get a signature from somebody at home. Just acknowledging that you did it. They're not checking your work. I don't think any of your parents are physics teachers, are they? Or physicists? Okay. I didn't think so. So this is just signing off. They know you're doing extra credit for the class. That's all. Okay, here's what you have to do. Every question you got wrong, you have to tell me the question number in this box. 1 for each question. Then you got to figure out what the correct answer letter was. A, B, C, or D. Put it there. That itself means nothing to me. This is the important part. Why is the correct answer the correct answer? You either have to show the calculation or explain why the correct answer is the correct answer. Without this, you don't get any points back. Okay, and it shouldn't be hard. Talk to people who got it right. What did they know to get it correct? Look in your notes. Look at the quizzes we've done. A lot of the questions on the test were on a quiz or very similar to them. And I gave you full explanations for all your quizzes. So that gets stapled to your test. You turn it in by next Friday. I'll give you half the points back, and that's it. Everyone should be holding on to their tests because they're great review for your end of marking period cumulative exams that we take. We take one every quarter. Okay. Any questions? And it's also great practice for the regions. I had a student last year who at the end of the year decided they were going to pull a magic trick, and they were going from a failing grade, wanted to pass the regents, so they hired a tutor. $75 an hour. And the tutor wanted to see every unit exam that they had taken all year. I was like, they have them. They emailed me, can I see copies of their tests? I said, they have them. They go, they do? They told me they don't have them. I go, they lied. They have them. The kid threw them all out. So now I said, well, sorry, I'm not giving you more tests. Hold on to them to help you review for the end of the year. Okay? These are like really important things. All right. If you only missed constructed response, I fixed all your errors on a constructed response question so you know what you should have done. I'll do the front row first. Oh, I'm sorry. Miranda, Eileen. So if you're eligible, I should have stapled your correction sheet. This is completely optional. You don't want to correct it, that is your business, but there will not be additional extra credit. It's either you correct these or you correct your labs, and they go towards different things. Extra credit on labs goes to labs. Extra credit on the test goes to the test. And that's it. Okay, any questions? All right, let's say you finish your test corrections. When are they due? Next Friday. You're not going to hand them to me. Okay, you are going to put every time you have test corrections, They go, this is what I call my turn-in bin right here. Do you see where it goes? You put them in here, and next Friday I'll take them and grade them. All right, folks, have a wonderful weekend. I'll see you Monday.